Alternating current fundamentals. Number 2, electrical generators and motors.
In the last video, the principles of magnetism were examined. You saw how unlike magnetic poles attract, while like poles repel. The important link between magnetism and electricity was demonstrated. You saw that a current-carrying conductor creates a magnetic field when connected to a DC source. In this video, basic principles of current and voltage will be reviewed. You'll be introduced to some alternating current concepts. A simple generator will be used to produce alternating current. You'll see how electric motors run on alternating current. Let's get started by reviewing some electrical principles at the atomic level.
Electrons are the particles orbiting the nucleus of an atom. Each carries a negative electrical charge. In certain elements, some of the electrons are only loosely bound to their atoms. When subjected to a force, such as voltage, they can be dislodged from their parent atom. They are then free to move from one atom to another. These are referred to as free electrons. Current can be thought of as the impulse transferred from one free electron to the next. This impulse travels close to 186,000 miles per second, the speed of light.
The electrons themselves do not travel through the wire at that speed, but the repelling and attracting effect causes the current to do so.
In electricity, the terms positive and negative are used to describe a difference in potential. If a material has extra electrons, it's said to have a negative potential. If it has a shortage or deficiency of electrons, it's said to have a positive potential.
Here's an important current law. Electron current always flows from an area where there's an excess of electrons to an area lacking in electrons. In other words, electron current travels from a negative potential to a positive potential.
The term voltage is used to describe this difference in electrical potential. Voltage can be thought of as an electrical pressure. The current flows as long as the difference of potential, or voltage, is present. The voltage causes the current to flow through the conductor. In some circuits, the current always flows in one direction, from negative to positive. You already know this to be direct current, or DC.
But there's another type of current that doesn't always flow in the same direction. This is called alternating current, or AC. An AC voltage source is indicated by this symbol, which you'll learn more about in the next video. As its name implies, this type of current alternates, flowing first in one direction, then reversing and flowing in the opposite direction. It's important to realize, however, that alternating current still flows from negative potential to positive. It is the polarity of the power source that alternates. Polarity is the property of an electric charge that refers to either a deficiency of electrons, designated by a plus sign, or a surplus of electrons, designated by a minus sign.
When the polarity of the source changes, the current changes direction. When this happens, you might think that anything it would accomplish while flowing in one direction would be undone while flowing in the opposite direction. But most transducers, which are devices that change one form of energy into another, need only to have a current flow through them regardless of direction.
For example, current through the filament of a light bulb causes it to incandesce due to the resistance of the filament. Changing the direction of current flowing through the filament will not affect its resistance. Therefore, the lamp continues to light. As another example, a heating element will heat on both AC and DC. The movement of the electrons through a resistance will produce heat, whether flowing continuously, as in DC, or changing direction, as in AC.
Basically, alternating current can do everything that direct current can, and more. AC has two important advantages over DC.
One advantage is that AC can be more cost-effective to transmit over long distances. A second advantage is that AC can be transformed to different voltage and current levels, allowing it to meet the needs of many different components in circuitry. Because of its changing direction, an AC voltage can be more easily increased or stepped up for transmission, as happens to the voltage being distributed from a power plant. Likewise, it can be decreased or stepped down before it reaches its destination, such as your home.
Stop the program and complete activity number 1. When finished, continue watching the program.